Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll solve a problem on power transmission through pipes. In our last lecture, already you have discussed the theory part related to this power transmission through pipes. And let's based on that concept, let's solve this problem. So here I have taken a question of a pipeline of length 2000 meter is used for power transmission. If 110.3625 kilowatt power is to be transmitted through the pipe in which water having a pressure of 490.5 Newton per centimeter square. This was power and this is the pressure. At inlet is flowing at the inlet condition. Find the diameter of the pipe and efficiency of transmission if pressure drop over the length of the pipe is 98.1 Newton per centimeter square. And consider the F value is 0.0065. So this is the question and these are the data are given. Okay. So this is the concept of power transmission through a pipes. Suppose through the pipes the fluid is flowing, and though the fluid is flowing in that, like how the fluid is flowing, it may come directly to this pipe, or we can join with an container to that, or any kind of reservoir to this one. So this may be the height of this liquid which is present in the container or in the reservoir. So when this fluid is flowing through this pipe, we need to find out what is the power transmission rate. And here what we need to calculate, we need to find out the diameter of the pipe and efficiency of the power transmission. So here power is given, and we need to find out from that, we need to find out the diameter of this pipe and efficiency of transmission. So for this, what are the data are given? Let's write down this data. So first, initially, these are the data is given. First one, the length of the pipe L equal to 2000 meter given. L equal to 2000 meter, and the power transmitted P, we can write this is 110.3625 kilowatt. And next is at inlet of the pipe, that made at this point the pressure value is 490.5. so this is power, and the pressure P equal to, so here let me write pressure at the inlet, that is given 490.5 Newton per centimeter square. So this one we can convert into meter square. So same thing, I can just write 490.5 into 10 to the power 4 Newton per meter square. Okay. So actually here it is given, if you see the pressure, the power to be transmitted through the pipe in which having a pressure of 490.5 at the inlet of this, so that is given. So next is find the diameter of the pipe and efficiency. So what we need to calculate here, we need to calculate the diameter and efficiency of power transmission if the pressure drop over the length is given 98.1. so the pressure drop at the inlet equal to, let's write 98.1 Newton per centimeter square. So this also we can convert into Newton per meter square. So that means 98.1 into 10 to the power 4 Newton per meter square. Okay. Now here this is the pressure value given, so we can find out the pressure head at this inlet point. This is the inlet part and this is the outlet from the pipe. So we can calculate the pressure head at inlet. What is the pressure head at an inlet? So we know that we can write this is H equal to P by rho G. The pressure head at inlet, in the sense, that means at this inlet part, what is the pressure head is situated at this point. Okay, so that is nothing but in terms of H. So H equal to, we can write this is P by rho G. So what is the intensity of pressure and density and gravity of that valve. So here we can write the pressure value is 490.5 into 10 to the power 4 and divided by rho equal to is nothing but 1000 into 9.81. If you calculate this, we'll get the value. So let's solve this one. This is 490.5 divided by 9.81. 50 into, this is 10 to the power 4, this is 10 to the power 3. So if you cancel it, only 10 will be there. So just multiply with 10 this one. So this is 500. So this is the head. Pressure head at the inlet is, we can write 500 meter. Now here one more term is given, F. The value of F equal to 0.0065. Friction factor. This is the value of friction factor. Now what we'll do, we'll find out the head which is available at the outlet of the pipe. The head which is available at the outlet of the pipe. So how we have seen in the previous theory lecture, like how to find out that one. So suppose this is the center line of the fluid flow and this is the H value, the head at the inlet condition, because this part is, as I told you, this is the inlet part and this is the surface level of the water. So now at the inlet condition we have calculated this pressure drop or the pressure head, and now we need to find out what is the head available at the end of the pipe, or we can say that is outlet of the pipe. So for this again we know that the head which is available at the outlet of the pipe or end of the pipe, that is formula is there, H minus HF. That means what is the head which is present at the inlet condition and what are the losses happen during this pipe flow. So losses during the pipe flow is basically we have to consider only the major loss. So major loss is due to the friction, and here we can ignore the minor losses. That means entry of this pipe and exit from the pipe, that can be ignored. Only we need to consider the losses through this pipe, that is minor losses. So this is the length. Anyway, so here head already we have calculated, H value we have already calculated, and HF value is need to be identified. So HF value, if you see here, is not given, and we need to calculate that. Okay, so the loss of head again, or you can say the loss of head through this pipe flow, HF equal to, we can write, this is, so what is the pressure drop? So here this the loss of head also can be calculated in this way, like what is the pressure drop is there, what is the pressure drop happened, that means initial pressure, and what is the final pressure, the pressure drop divided by rho g, that also we can calculate. Okay, one thing we can consider the loss of head by this by the help of friction, like means the major losses, or else we can directly write this, the loss of head equal to what is the pressure drop happened divided by the rho g. So if you see this one, you can find out, not 9 point, this is 98.1 into 10 to the power 4, and denominator we have, like 1000 into 9.81. So if I cancel this one, like you multiply this of this, 0 1 will be gone, then here 10 to the power 4, here 10 to the power 2. So you can write this is 100 meter. So this is the loss of head, HF. Now as we need to find out this head at the outlet condition, what the head is present at outlet condition. So what the head is available at the inlet condition, 500 meter, and what is the loss of head during this flow, that is 100 meter. So just minus this one means we'll get 400 meter. So this is the head of this outlet at the outlet condition. Now we need to find out the diameter and we need to find out the efficiency. These two things need to be calculated. So for calculating this diameter and efficiency, we will go directly to the power. So now the power transmission P, this is equal to, we have the formula, that is rho QG, and here H minus HF and divided by 1000. This much kilowatt. Okay, rho Qg H minus HF by 1000. So this is the power transmission formula. Now here we just can put the value of P value given, power transmitted value was given 110.3625 and rho value we know that this is 1000 and Q value not given, so Q as usual we can keep it, and G value 9.81 and H minus HF, that value also we already got here, so no need to put bracket, directly we can write this 400 divided by 1000. So here if you see only Q is unknown, remaining value is known to us, so we can write what is the value of Q. So here 1000 cancel and 9.81 this is 400, that means 110. So what I'll do, just 110 point, this is 3625 divided by 9.81 divided by 400, we'll get 0.028, 0.0281. Okay, this much meter cube per second. This is the discharge value Q. Okay, now from here what we can calculate discharge value. Why we have calculated discharge? Because we need to find out the diameter of the pipe. So discharge is directly related to the diameter of the pipe, because as per the discharge equation we know that Q equal to AV. So here A equal to pi by 4 D square into V. So now V value also I think not given in this equation. If you see, V value is given, no, V value is not given. So this much data are there which is given in the question, and from here solution. Now so what we can write here, Q value we have calculated, so let's write down Q equal to 0.0281 equal to, this is pi by 4 D square into V. So this one we can write like in terms of V. If you write this one in terms of V, just keep it like this, 0.0281 into 4 and divided by pi D square. Okay, so what we'll get if you solve this one, let's see, this much into 4 divided by pi, answer 0.035, 0.0358, 0.0358 divided by D square. So this is in terms of the velocity value, in terms of diameter we got it here. Now we know that the head loss at that what I told you here, head loss at this fluid flow, we know that equation we can write HF equal to, we know that HF equal to 4 LV square by 2 dg, 4 LV square, 4F LV square by 2 dg. So now here HF value already we have got, we have already found from the previous equation HF value here. Okay, what is the head loss? So now what I'll do, I'll just put this value of HF here and remaining other values, then we can find out something like 4 into F value is given 0.0065, so which is unknown here. L value I hope given, length 2000 meter given. Now here unknown is V. So V, what I'll do, I'll just keep it V, later keep the value of V. Now 2 into diameter of the pipe D. Okay, now if you solve this one, we'll get the value. Let's solve it. So 4 into 0.0065 into 2000 equal to, divided by 2, again divided by 9.81, 2.65 V square we got here, 2.5 d square by d. Okay, so now what I'll do, I'll just put the value of v, what I got here, the value of v in this equation. So if I put the value of v in this equation, then again I can write 2.65 by d. This side already our HF value is there, that is 100 is there, and v value what? Just put the value of v 0.0358 divided by d square whole square again. Now you can find out the value of d. Okay, let me first find out this value, how much we are getting. 2.65 into 0.0058, yeah, 358, sorry, 0.0358, 0.0358 again, 0.0358, yeah, we got this 0.00396. So let's write down this value. Now here I'll write 0.00339 and divided by denominator, what will be the d squared and to the power square d4, and this is d to the power 5. So this is the value. Now what I'll do here, d to the power 5 equal to 0.00339 divided by 100. So this one I can write again. I need to find out the value of d, so I can write in this value in terms of like this is 100 to the power 1 by 5. Okay, so let's find out this, how much we are getting. Again this one divided by 100. Now to the power bracket 1 divided by 5 close 0.1277. So we got 0.1277, this much meter. If you want to convert in terms of millimeter or centimeter, that also you can write. So 27.7, this is millimeter. So this is the diameter of the pipe. Okay, now second term we need to find out the efficiency of power transmission. That is very easy. This is the formula like H minus HF by H. So this is nothing but H value is 500, head loss is 100 divided by 500. So we'll get here 0.8, or you can write this is 80% of power transmission. This is the efficiency. So I hope you understand this problem, how to solve it. Mostly these are the data should be given, and we need to find out as per the questions here asked, diameter of the pipe and efficiency of the transmission. Two things need to be calculated here. So for calculating these things, as I told you, like first we write down the data given here. What are the data are given in this question? So this is the data given part, and in this also I have mentioned what I need to calculate here, diameter and efficiency. For that you go for 1 by 1 formula. This is the pressure head we can write at the inlet condition, and then this is the power formula is there, and meanwhile I can calculate the head loss also by using this concept, and H at the outlet, the head at the outlet, this is one formula. Next is this is the discharge formula. From here I can find out this velocity value, and in the velocity also in terms of diameter, because both are unknown here. So let take the help of this like major loss. So by putting this value we can get the value of diameter. So this is our first requirement. Then efficiency value also you can calculate by using this formula. I hope you understand this problem. Still, if you are having doubt regarding this, you can give a comment on the comment box. Thank you.